Alrighty. So for this week, we are going to be talking about nominal rigidities, sticky prices, if you will, menu costs. Yeah, not really sticky prices, I guess. Menu costs would be the right way to say it. One reason for sticky prices, one reason why prices don't change as much as we might think they should or they would in a frictionless economy. It's also a chapter that has a lot more to do with macro 101 models than other chapters. You may have seen that there's an aggregate demand function, which basically comes right out of macro 101. Does supply drive demand? Does demand drive supply? Demand drives supply in terms of macro 101. If you want it, it appears. That happens in this model. In any case, let us get started with our usual Kahoot, which I jiggled with this morning to make sure that it was 30 seconds for each question. Teach, we're going to teach. Uh-oh. I think this is the right one. How many people do we have today? 11? Did I see? Oh my gosh, it's so small. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people today. So last time everybody said you have a exam. This time not as clear. Can you see my screen? I'm noticing nobody's joined yet. Okay, there we go. Pure chance. One, 2, 3, 4, 5, 6, 7, 8. I said we had 9 people and then one of them left. So while you're joining, the plan today is to do this and then talk about the last problem from problem set 2, I think, which is an interesting one. 3, I'll give you another, okay, that's 8. I think we have 9 people here, but Labu20AD just joined. Give him 2 seconds, a couple seconds to join. There we go. Thank you. Let's get started. Nominal rigidities. Full screen. If menu costs are large, how do firms react to small monetary shocks? Yeah, so you recall that it was the other asymmetry that we were sort of that you kind of show in the textbook, right? So or in the slides. So the idea is that if the menu, even if the menu costs are small, that can make firms potentially not change prices, even if there's a relatively large shock. But if menu costs are large, then and then even more so, firms aren't going to change their prices if there's a monetary shock. So it's a bit vague, right? Big, small, but this is kind of the opposite situation than in the textbook. So if the menu costs are very big and the shock is really small, there's no reason for firms to change their prices. In our menu cost model with market power, what is the welfare maximizing monetary policy? All right. So a lot of people said indeterminate, but I mean, I think a point from the slides was that when you have market power, that's like monopolists. They're going to produce too little, socially too little. So, you know, as a government, what you want to do is induce more production. Okay. So I think that there was a part where we talk about like the socially optimal level of production in the slides was 1, and the decentralized equilibrium had production less than 1. Okay, so here the government wants to stimulate the economy simply to overcome this this market power that monopolists have that's creating too little production. Oops, I should have let that adjust. Sorry. Why is there no Euler equation in this model? The other models we looked at all had an Euler equation, right? Relating consumption tomorrow to consumption today. Why in this model is there no Euler equation? All right, that's right. So this in this model, there's only one period. So it turns out that actually in models with monopolistic competition, like the model we looked at here, it's relatively hard to make them dynamic. Now that doesn't mean that that never happens. You saw that in the Romer model. That was a dynamic model that had monopolistic competition. But yeah, this model is not like that. There's just one period, one shock. There's just a you know, one utility function that's for one period. So there's no Euler equation because there's no concept of tomorrow versus today. The Euler equation relates consumption tomorrow to consumption today.
If you wanted to expand the model and add more.
Do you go like regularly too?
All right, profits are higher when elasticity of substitution is higher, elasticity of substitution is lower, or indeterminate in this model. Yes, when it's lower, right? Because the idea is that this is a monopolistic competition model. So firms have a monopoly over their own brand or their own variety. So you can think of it like cars again. So you've got Honda, or well, yeah, you've got Honda, Toyota, whatever, Mercedes Benz. Each one is different, and there's sort of if people really prefer to have one type of car, that's kind of like saying there's not very much substitution between types of cars. And then these companies can really charge a lot of money. If you want to see it in terms of notation, you can do that. More, I have several chats. Oh, okay. Seems like that's something I need to respond to. So you'll recall that in this model, or in this class of model, if sigma is the elasticity of substitution, then the markup is sigma divided by sigma minus 1 times the cost of production. Okay, so, and then we assume that sigma is greater than 1, so that goods are substitutes. All right, and you can see here that when sigma is very, very high, close to infinity, oh, then this is, I said the markup, this is the price that's charged. Okay, so then if sigma is very high, then the price is equal to the marginal cost. Okay, if sigma is very close to 1, then the price is, you know, then this thing diverges off to infinity. So then the price is much higher than marginal cost. And of course, the profits are going to be price minus cost time quantity. Right. So, you know, when this gap is very large, then I mean, quantity adjusts as well. But, you know, if let me put it this way, if P is equal to C, then the profits are 0. Okay, so when sigma is very, very high, so that there's a lot of substitutability between goods, then there's no profit. When sigma is closer to 1, then you get very high profits. Okay, so that's the idea. Oops, got to erase it or else it's going to appear on every slide. Why can firms make an overall profit in equilibrium? Is it because we don't have any capital, because of menu costs, because we have a fixed number of firms, or monopolistic competition? Overall profit. Yeah, so this is a bit of a tricky question. All right, I was being a bit tricky here. So, monopolistic competition by itself doesn't guarantee that a firm will make a profit. And why is that? Because imagine that we have free entry. Then, so an example actually might be the Romer model. So if you recall, in the Romer model, anybody can create a variety, right? So you have to pay the cost that it costs to develop a new idea, and then you get this stream of profits going off into the future. But you'll probably recall that in that model, we set those two things equal so that the stream of profits is equal to the cost of producing an idea. Okay, so when you take the fixed cost, the cost of producing that idea into account, actually overall, there's no profits, right? There's operating profits. So like net of the fixed costs, then these guys are making a profit. But when you consider the fixed cost as well, then there's actually not any profit. Okay, so and that comes from this idea of free entry. So anybody can enter and get a new idea, and then develop a new idea, and then sell it for a profit. And since you've got that free entry condition, then that's actually going to drive the profits down to zero. So the thing that allows firms to make an overall profit, so not an operating profit, an overall profit is actually the fact that here in this model, we fixed the number of firms. Okay, so as you recall, I think we're integrating from 0 to 1. So like the number of varieties is just measure 1. Any questions about that? This was a bit tricky. If we would have had perfect competition as well, we wouldn't have had any profits, even with a fixed firm number. Well, is that right? Yeah, that would be right. So I guess formally you need both ingredients, but monopolistic competition by itself is not enough. And even if you have a fixed firm number, you could assume that there's perfect competition, but that's only if firms, even though there's a fixed number of them, they think that they themselves are very tiny, so they can't influence the price level. Okay, no questions? I'll move on. Can the government intervention increase welfare in the menu cost model? Oh, I just realized I didn't share this with sounds. You guys can't hear all this wonderful Kahoot music. Yeah, so it can, right? So it goes back to what we were talking about earlier, that because we have this market power, there's actually less output than is socially optimal. So the government can stimulate the economy to produce more, and that's actually a social good because it sort of counteracts a little bit the market power of the firms. Why don't governments constantly stimulate the economy to reduce market power in the real world? They do. Not enough knowledge of economics. Expectations adjust, or the central bank is not the government. Exactly, right. So you know, if the government did that every single period, if they're always going to print more money, then firms are going to expect the government to print more money. And then, you know, in order to actually surprise the government, the government would have to print even more. And you know, that's not sustainable, right? And then even in that case, I guess the firms would expect the government to do that. They're playing a game between the firms and the government. So they can't constantly do it because it stops being effective, basically, because expectations adjust. There needs to be a surprise. If you actually recall um, the way that we kind of set up the way that the government affects firms in the model is, if you recall, firms have an expectation about something we called in the model M divided by P, right? That's like the real amount of money in the economy. And then the government shocks that. So then we have like an M prime divided by P. And then the firms have to decide, do they change their prices or not? So, you know, the firms already expect M divided by P. So the government would have to constantly surprise them. And that's not easy to do. Now, this is a hard one. What is a real rigidity? They talk about it a lot in the textbook. Is it something that makes gain to adjustment small relative to output change, wedge between average and marginal cost, cost of adjustment, for example, menu cost, or any sort of distortion from perfect competition? Yeah. So it was something that I talked about in the slides, and it is a little bit subtle, but the idea is this idea that, I mean, think about this menu cost model, right? So the idea is, suppose that there's a negative shock and none of the other firms are adjusting, and you have to decide if you want to adjust. All right. Suppose the elasticity of substitution is very low. Okay. That means that you don't actually gain that much from adjusting, because even if you lower your price, the other firms, you know, people are still going to buy from the other firms since the goods are not very substitutable. On the other hand, if the elasticity of substitution is high, then when I lower my price, then I get lots more business because all kinds of people kind of jump into my business. Okay. So it's like, even if when the elasticity of substitution is low, then even if there's a big negative shock, it doesn't really make me want to adjust my prices very much. Okay. So that's an example of like a real rigidity, is this low elasticity of substitution, meaning that even a big shock in terms of real terms won't make me really want to adjust very much. Okay. Pure Chance got 4 out of 8. Hey, that was actually totally expected. All right, very good. Okay, so I'll briefly stop the share, and I will pull up my slides. Leave page. Let's see here. Da, da, da. 2021, David slides, nominal, Rigidities. Where are you? There you are. Okay. Now I will share again. Okay, here we go. Ask away. Is it the case that I can't hear you guys?
Test. Can you hear
I
us?
see that Les is unmuted, but I'm not sure that I can hear you. I think
I
you're
hear
right.
you,
Okay,
Les.
I can hear you. Let me
I can hear you, Kari, as well.
try sound settings here.
That's great. Guy now. Such a boomer. Hope this is recorded and he's gonna watch this again and hear us talk about this.
Okay, microphone. That's fine. All right, try it again.
Hello, can you hear?
Okay, now I can hear you. Yeah, I don't know what I had. That there was something weird with my sound settings, but I can hear you now. Now I feel a little bit bad that I was saying, does anybody have any questions during the Kahoot? And I couldn't actually hear if anyone had any questions. So were there any questions during the Kahoot that I could answer now? Or any other questions?
Students
Yeah.
were
I'll
I
stop
gotta
talking.
hit quest real fast because my girlfriend also has a class.
yeah.
Oh, okay. I see. It was funny. I was teaching another class this morning, and it was like it's a discussion course, a little different than this one. And I asked like several of the students to unmute and discuss some topic, and one of the guys was muted. And I said, "Would you please unmute?" And he said, "I can't because my girlfriend has class right next to me." So it was common problem apparently. Anyway, okay. Yeah. So let me know if there's questions about this, Kahoot, anything, economics in general.
Does the output level being less than 1 have any meaning, like just a number, or is it just, could it be anything? Like that the level is number 1, could it be also 5, you know, if you just make the model different? Because the model in the end depends basically only on the markup, the output.
Yeah, that's right. So we derive it here. So I think that this pi divided by p, that comes from sort of all the firms being symmetric. So this one here, I don't think is something that is going to change. But you notice there's this step. So there's, well, first there's this step, is that we get from w divided by p to L gamma minus 1. So that's sort of an additional assumption in the model that the labor supply has this shape. And in fact, I think that part of the reason that we assume that the labor supply has this shape, you know, if you remember, this comes from the utility function at the very beginning. So, you know, and it has this idea that the amount that you don't like labor is convex. So it's like, you know, you're not going to provide sort of an infinite amount of labor, but also it's a little bit weird because it says that there's no physical limit on how much people can supply labor in the Ramsey model. Was it the Ramsey or maybe the RBC model? There we had a different assumption about labor. If you recall, we said that they had 1 unit of time, and then they had to decide what fraction of that unit they wanted to supply for labor. Notice we're doing something different here. And part of the reason is because it gives us this nice functional form, right, on this step right here. So so I guess, so that's one thing. Second, check out the production function. It's just y equals L. So, you know, we need this step as well. All of those things are part of the model that are not sort of things that are necessary or that, you know, are fundamentally important. So no, I don't think that you would always need that output is equal to 1 when the economy is at its social optimum. That comes out of the particular structure of this model. What's more important is that there's what isn't really part of the structure of this model is that when you have monopolistic competition or any sort of market power, then the decentralized equilibrium is going to be less, decentralized equilibrium output is going to be less than socially optimal output. And that comes from this old-fashioned monopolist problem that I drew in the slides, but you guys also had an undergrad, and I could just sketch it here. I sketched it like 5 times in the slides. But you'll recall I did something like this, and then like that. And then you remember you have like, say this is price, this is quantity, here's the demand function, here's marginal revenue, MR, here's marginal cost, MC. So the social optimum is this quantity, where price is equal to marginal cost, but the monopolist sets marginal revenue equal to marginal cost. So the monopolist is charging this price. You can see that quantity here under monopoly is lower than sort of socially optimal quantity. That part's general. Okay. The fact that it's one is not important. That comes out of the structure of the model.
Okay, thank you.
So this model, something that I really dislike about it, if you hear me, David,
I can hear you.
is that there is only one period, but then you conclude it with expectations. And you said one thing in the slides about tricking firms into producing more than they would is optimal. But we never get to the next period when they punish you for tricking them. And so all conclusions about expectations in the model are built on lies, and like therefore I dislike this model for that reason.
Fair enough. So so the place where the expectations enter here, it enters very subtly. It's actually, let's see here. Yeah, I say here, MP changes, money's not neutral. Right. So, I mean, this is it, right? So, I mean, this is the only part where I talk about expectations in all of the slides. So the initial equilibrium, what the firms expect, is here. And then what actually turns out is this level of money divided by prices. So the whole model absolutely is based on tricking firms. There's no question about that. But I mean, the but there is that that's something that's actually going to be true in, I believe, every single model we look at in the rest of the business cycle section of the course. So here you got these menu costs. The government is tricking the firms. The next one we're going to look at is called the Lucas Island model, or the imperfect information model. So there, firms are going to be observing their own demand for their product. And if they see that the demand goes up, they're not going to be sure whether it's because people just suddenly start, their product is really taking off and people are really enthusiastic about it, in which case they want to sort of, up their production and lower their price to take advantage of this new expanded market. Or if it's that the government just generally printed a bunch of money and people are demanding more of all kinds of goods across the economy, in which case there's going to be inflation. So then they don't want to actually change their output. They're not going to be able to totally disentangle those two things. So again, the government can trick them into producing more. Finally, we're going to look at a DSGE model. And there, again, there's going to be expectations about monetary policy. And if the central bank does something that the firms don't expect, say prints more money, then that's going to increase output as well. So every single model that we're looking at is all based on tricking firms. Now we can think back about like the real world and think about what sort of policies of an actual central bank have an effect on output. And I think that many people believe, I don't know if it's, I'll be a bit agnostic about it. Don't know if it's true, but I think what a lot of people believe is that it's only when the central bank does something unexpected that it actually has an effect on the economy. If the central bank says, we promise that we're going to keep interest rates, whatever the interest rates flat for the next 6 months, and then 2 months later they say, we are still keeping interest rates flat for the next, 4 months, there's going to be very little movement in the market because everybody expected them to do that. It's only when they do something that people didn't expect them to do that they have a real effect. So, I think that's like a fairly standard intuition, for better or worse. But it certainly is the way that these models work. So that's a good point. So when you say you don't like it, do you mean you don't like the fact that all of monetary policy is basically based on tricking, on sort of lies and deception?
Yes, but mostly just that they don't take the behavior into account, because you kind of came into the behavioral economics and of the central bank. Like the central bank obviously says something every period about the future, and things do change. People know that things change, so they can't always be truthful in what they say. Just that's how the world works, right? But if they deliberately lie to do something, then they're never going to be trusted again in the future. So what they say next period isn't worth believing. So the people just do whatever they want, and then the central bank like loses control of the economy, or like the kind of, I'm going to call it like the soft grip of the economy.
Yeah, I think that's
So-
totally fair.
And like, and then I'm also thinking about these models, like, should I just learn them and then believe them as the holy truth, and then when this class is over, I'm just going to forget all about it? Or should I think about why they suck and how they can be improved? Like,
Well, I mean, you might. So, I mean, you might think that it's. So, excuse me. So, there's two ways to parse what you said. So, you could think that these models don't accurately describe the world, or you could think that I don't like the way that monetary policy is conducted because it's based on surprises, or, as you said, lies, if you like. So, whether the models describe the real world or not, that's something that we can debate, but certainly we do get this effect that when the central bank makes a surprising announcement, there's a real impact on output. So, that's one of the justifications for these models is we have the real business cycle model. And the real business cycle model, it doesn't matter what the central bank says, right? The central bank can print money, it can destroy money, it can do whatever it wants, say the interest rate is whatever. But in the real business cycle model, the whole fluctuations of the economy are all based on real shocks. Okay, so I think what happened in maybe like the 1980s is that people had these real business cycle models, and then you had the central bank that was making announcements, and it seemed to have an effect, at least in the short run. So then people were a little bit unhappy that their models couldn't describe what was happening in the real world, so they came up with these sort of models. Although I should be careful. I think this model is definitely a new Keynesian type model. The next one I think was actually developed in the 1970s. But yeah, so I mean, maybe this is the real way the world works, and then this is just a positive description of what happens. If you don't like it, then maybe you think that there should be a different model for money. Maybe you like cryptocurrency or something. Some people think that it's actually good that the central bank can do this sort of thing. Maybe it helps smooth the business cycle, or maybe it doesn't.
I don't believe in cryptocurrency. I'm just going to say right now. So please don't.
Oh, I won't be.
Yeah.
How about
maybe
gold?
No. Yeah.
Okay.
Maybe all of these books are just wrong, or like old.
But what is it? So you think that this doesn't accurately describe the way the world works? That's the issue.
It describes a simple world. It describes the Robinson Crusoe world, right?
You mean a one-shot world?
Yeah, and it obviously like world is difficult to put into a model, right? We need to make assumptions and we need to simplify things so that the output is worth it in the end, right? But this model just like, yeah, it says something, but then the expectations and stuff, and I'm just like, I don't see the inputs about the expectations like truly being believable, because like we can't go further. We can't look at more periods because the world doesn't end tomorrow. It's never going to end in my lifetime, I think,
Sure. Yeah. So I think you could add dynamics to this model. In fact, the most popular type of model that's actually used by like central banks that has a flavor of this menu cost model in it is called a Kelvo pricing model. That is a dynamic model. And then the way that model works is it doesn't explicitly model the menu costs. What it does is it says that firms are only allowed to change their prices every so often.
Yeah, I've seen the model. So there's like a likelihood of X amount of firms getting to change their price this period,
Exactly.
right?
Exactly. And then that has a bit of the flavor of this menu cost model, but then it's simple enough that you can put it into, part of the problem with the menu cost model is that it's a game, right? So you saw, I think that maybe even one of the questions in the problem set is about this, but what we're looking for here is an equilibrium. I'm not sure if I made this point actually in the talk over the slides. So let me show you where I talk about it here. Right. So, what we want to find out is if no firm's changing their price is an equilibrium. Okay. So what we do is we assume price doesn't change. So we're going to assume that all the other firms don't change their price. And then we're going to look at one firm. And since all the firms are symmetric, it's like looking at any firm. And then we're going to say, is it worth it for you to deviate? None of the other firms change their price. Will you change your price? And if you will, then no firm's changing price is in equilibrium. Excuse me. Then if you will change your price, then no firm's changing their price is not in equilibrium, because then if everybody's not changing their price, I'm going to deviate. So at least one firm's going to change the price. And then that's not in equilibrium any longer. Okay. So all we're showing is the existence of an equilibrium, but we're not showing the uniqueness of that equilibrium. So in fact, even in this model, the one that we did in the slides, there could be another equilibrium where all the firms change their prices. Okay, all we're showing is that one equilibrium exists. So you can imagine that if we put this into dynamics, now you have a very complicated model where there's all kinds of uncertainty going on because there's more than one equilibrium, and it's just a little bit, you're saying it's simple, it's actually a little bit too rich to put into a dynamic framework. So I think this idea goes into this Calvo pricing model. But yeah, does it describe the real world? I don't know, but central banks seem to think it does.
Does any of the simple models we learned describe the real world?
Yeah, so let me be a lawyer. Let me defend the models for a moment. So if I were to defend them, I would say this model is showing you a mechanism for why things that we observe in the real world might happen. So I'm saying that it could be that even if we have I'm showing you, it's like a existence proof. If we have small menu costs, which seem like, firms could actually have small menu costs, it does actually cost something for the firms to update their prices. In that case, it could be that for rather large shocks of output, the firms choose not to change their prices. So, you might have thought before I had written down this model that, menu costs could never be large enough to justify firms not changing their prices during a moderate sized, economic downturn or a moderate sized economic boom. But this model is saying, well, here's some reasons why actually maybe that's enough to stop them. So it's not necessarily like I want this model to precisely match everything about the world. Rather, it's saying that it's like an existence proof saying that this mechanism, which you might have thought wasn't enough to explain why firms don't change their prices, actually can be enough because of the interactions between the elasticities and the small menu costs. So there's my best lawyer's defense of this model.
Yeah, I will accept that. But also just because I would like to hear somebody else's opinion, so we aren't just having a conversation, the two of us.
That'd be great. So this model actually is I think I mentioned this a minute ago, but this is the first time that we're seeing something that's more like macro 101, right? We have here an aggregate demand function, and my opinion now, after having taught macro 101, I taught it this year for the first time, is that macro 101 is all about the government's role in sort of steering the economy and here we see it. It pops out. There is a role for the government for the first time in our section on the business cycle here. Any other questions about the model? I'm just waiting for a second. I don't want to say the B word to make sure that I don't cut anybody off who wants to ask something. All right, well, the B word is break, and I will give you a 10-minute one now, and then we will come back and discuss the last problem from problem set 2, which is about the Romer growth model. All right, so let me set the countdown timer. It was a nice discussion, by the way. Okay, talk to you in 10 minutes. All right, so before I jump into the problem, let me just field Elon Musk's question here. What do you think of the unusually high ratio of S&P market cap to GDP? I mean, you want me to give my like shoot from the hip answer? So I mean, right now,
Did you just fuck up your sound? Or your mic?
okay, can you hear me? I'm not using my speaker in my headset. Is it okay?
It's worse, but it's
No?
okay.
Okay, so yes, you can hear me now. Okay, I'm going to assume that you can hear me.
Yes.
Somebody confirm it. Yes, excellent. Thank you, Kaijon. All right, so anyway, let's see here. Oh yeah, I was saying that I'll field Elon Musk's question about the S&P market cap to GDP. So this is now shooting a bit from the hip, but you know, the stock market is forward-looking, whereas you know, right now we are in the middle of a pandemic. You know, this is maybe a temporary shock to the world GDP, and S&P 500 is thinking about what things are going to look like going down the road. So that's my initial comment about it. Is this, that's not the donut economics lady, is it? Let's see here. Thanks to productivity, real GDP growth probably is higher and inflation lower than reported, suggesting that the quality of earnings has increased significantly. Yeah, there's something to that, right? So people say things like, well, actually, if you think about it, you know, you don't pay anything for Facebook, and isn't that great? So there's something to that.
I mean, we don't pay anything for Facebook, but they gain from
I mean,
us
one thing
data.
I'll say is that the national statistical agencies that are putting together price indices, so I mean inflation, you know, how do you measure inflation? It's difficult. Why is it difficult? Because the goods that are available in 2020 are different than the goods that were available in the year 2000. You know, a computer bought in the year 2000 is not the same as a computer bought in the year 2021. A telephone bought in the year 2000 is not the same as a telephone bought in the year 2021. So when I think about sort of how prices have changed, I can't just look at the change in the price of computers. Probably actually those haven't changed that much. To buy like a desktop computer, it's not really that much different today than it was in the year 2000. It's just that the quality is much, much higher today. And also the internet is better. So both the quality in terms of the components and also the quality in terms of what I can do with my computer. So that's a real concern. It's not like the agencies that put together these price indices don't know about that concern. So they actually have some fairly fancy methods for trying to tease out the actual level of inflation. And a little plug for my own research. I actually have a paper where we are using a sort of a non-standard method to back out the inflation rates. I'm wondering if I can explain it in just a couple of seconds. My own research might take a second to explain it. Let's see here. So I think I can do a whiteboard here somehow. I've never actually done this before, but I've seen other people do it. Hide video panel. Anybody know how to do this? The whiteboard? If not, I'll just do it a different way that I know.
It's my own program on my computer. All right. So okay, so it turns out that there's this relationship that's like well documented in empirical literature, where if we look at sort of income, so here we'll put something like real income, okay? And then here we put percent of spending on food, okay? So the percent of money of your total budget that you spend on food. So I'll put percent food, okay? And then I think we have to put a log here. This is log real income. Okay, so it turns out that there's like a empirical literature that shows that this looks kind of like this. If you look at like households, then like households that are poor spend more on food than households that are rich. And in like sort of logs, it's actually linear, more or less linear. And of course, if you look at the data, the data looks like there's just all kinds of data points around this line, but more or less it's kind of a downward sloping line. And this is true both within a country, across countries. It seems like it's been stable for like 100 years. So this is called the angle curve. Angle curve. Maybe the food angle curve, because you can do this for other goods as well. So you got this decreasing linear curve, okay? And this is in real income. Now, suppose that I observe this same line, but now let's say I put in nominal income. Okay, so suppose that I observe in 1 year, this relationship looks like that. And in another year, let me try to do this the right way. We want it so that somebody with a higher income is going to have the same food share. So it would be like this. Okay, so what this says is, if I believe that this angle curve here is constant, so this thing is constant, now I've drawn this thing with nominal income. I don't want to make it red because the blue and the red line are 2 different years. I'm just going to write in black. Now I have nominal income here in logs. And here's percent food. These are just empirical lines that I've drawn somehow. Okay. Now what I see is that a person that had a nominal income here in this year, let's call this year 1, we'll call this year 2, has the same food expenditure as a percent of total expenditures, say, as the person with this nominal income in year 2. Okay, so actually I can take this gap between these two lines and I can call that inflation. Okay, so we can actually kind of use this. So this way, look, I didn't measure any prices. I didn't do any corrections for the internet or whatever. All I'm doing is I need to observe all expenditures and I need to observe the fraction spent on food. This is like another way of calculating inflation. Okay, so we do this, and you can use this to sort of discipline like a consumer price index measure of inflation. And indeed, what we find is that the consumer price index is sort of overstating inflation. So people are actually like, GDP is higher than what you'd get from CPI calculation, but it's not like a big, like not a huge difference, like a few percentage points different. So yeah, that was a long answer, but it was just a plug for my own research. So I don't mind going telling you guys about what I'm up to. But anyway, yeah. So I think Kathy Wood's onto something, but I don't think it's gonna totally correct for the fact that the S&P 500 is much higher than the ratio of S&P 500 to GDP is much higher than it was in other years. It also could be related to the fact that other measures of both market power and profits are at record high. So, you know, it could actually have something to do with just concentration in the economy, which is a bad thing, right? More monopoly power among big firms. So S&P 500 tech firms often have monopolies, or more or less monopolies. You know, Facebook owns WhatsApp, Facebook itself, and Instagram. These are all Facebook companies, and it's very hard for me to imagine a competitor emerging there. So, you know, Facebook has a lot of market power, and you might say, well, wait, you can use Facebook for free, but you know, Facebook is charging money for ads, right? So it's not free. Somebody's paying. You're just you just don't pay anything to use it. You could imagine another model where you would pay something. Any questions about this? I'll send you the paper if you're interested. Actually, it's not on my website right now. We had a working paper version of it, but then we took it down because we were applying for some money, and they don't like it if you
even hear us?
Have like preliminary results online. So we didn't do that. I took it down, but now we didn't get the money, so we'll put it back up. And I think we're gonna update it a little bit too. We've been working on it.
I'm gonna go with no.
So yeah, so that's that. Shoot. Hold on a second. I don't know why I have so much trouble. Actually, I always use Linux, or I always use Windows because I usually use Linux, and then I
think this has something to do with the headset you have. You can hear me.
Okay, can you hear me? I can hear you now, but I didn't hear whatever you just said. Are you sorry?
I asked, can you hear me? That's what I asked before.
Okay, now I can hear you. I apologize. Was there a comment that someone wanted to make at some point?
I think it's something to do with your headset, because you're using stereo as the output, but then you're trying to use the input for the Bluetooth hands-free stuff, and that doesn't work.
I see. Can you actually see what I'm choosing here?
No, but we saw it just for a little while you were.
Here you can see. Can you see it now?
No, can't see this.
Okay. Yeah, I don't know. Oh, you're saying I shouldn't choose stereo. I should choose headset.
I think you have to have both audio in and out on the mic free setting on the Bluetooth.
I gotcha.
But then you're going to get worse audio quality, which kind of sucks if you're going to listen to Kahoot music.
Yeah, that's true. Okay. Well, if it cuts out again, I'll try that, but hopefully it won't. I actually have a different standalone microphone, but whatever. Okay. Were there any questions about my about the way that I had this research set up?
Yeah, what happens if you change the y-axis to percentage of something else? Not food, but...
Well, then it'll look different, right? So, I mean, if I was going to do something like percentage on wine, that looks like this.
But what other goods are there like food where we always kind of...
Yeah, so I think those are called like, there's a word for that, right? There's necessities and luxuries. So I think this is like called a necessity good, and this is called a luxury good.
Where you go housing or water prices or whatever.
Exactly. So housing maybe would look like food, something.
What about just like expenditure to the government? Not taxes, but maybe just to the local government or something like that, small case.
So taxes paid to the local government?
Yeah, something like that.
So, I mean, of course, it depends on which country you're in, but often those are things like property taxes, potentially sales tax or VAT. I don't know how that changes, but, you know, property, I would expect that would be increasing with income, even as a share, just because poor people rent. And then in terms of VAT, actually, you probably know that poor people pay a higher percentage than rich people. Because
but that's the same as for food, where they pay higher percentage of their total income towards food.
That's right. Yeah, that's right. I actually, so I have a different class where we're talking about those issues more, and I don't want to get again sidetracked here, but
Yeah, we saw them. You started uploading them on YouTube. Came up in
oh
my
yes,
feed.
exactly.
Your other child.
So we're talking there about fair taxation, and you know, one thing about this VAT, I always heard the argument that um, that you know, VAT was a regressive tax because rich people save a lot of their income. So it means that they're spending less as a share of income in terms of consumption. And VAT is on consumption, right? So poor people, they spend 100% of their income on consumption. Rich people spend a lower share. So then therefore, sort of as a share of income, you know, rich people are actually paying less in terms of that as a share of their income. But then in the book, it says that that's because I'm thinking of the wrong tax base. I shouldn't be thinking about income. I should be thinking about consumption. So, you know, why am I thinking about income? It's not, there's no law of nature that we should be thinking about shares of income. That was an interesting argument. But yeah. If I were to put log expenditures on the x-axis, then VAT would just be flat because, you know, if there's no exemptions, then you just pay a fixed share of total expenditures in VAT. But yeah, let's move on to the fun problem from the problem set before we get too distracted here. Okay, so I have to find where this is. I want this one, but I don't know where it is on my desktop. Boy. Here it is. Okay, so we make this nice and wide so you can see it. So the problem that was assigned was 3.9. So again, an interesting one that has a lot of intuition for the model, I think. So it says, suppose that policymakers, realizing that monopoly power creates distortions, fair enough, they put controls on the prices that patent holders in the Romer model can charge for inputs, embodying their ideas. Specifically, suppose they require patent holders to charge, get my chat up here so I can make sure I can see if you guys can't hear me. Suppose that they want the patent holders to charge delta WT divided by phi. So you may recall that in the model, the sort of market decentralized version would be WT divided by phi. So here the patent holders, or the government is forcing you to charge less than the price that you would charge if you could set your own price. Okay. So the question says, how is that going to affect the equilibrium growth rate of the economy as a function of delta and the other parameters of the model? Does a reduction in delta increase, decrease, or have no effect on the equilibrium growth rate? Or is it not possible to tell? Okay, so that's part A. And then part B says, explain intuitively. I love explain intuitively questions. Why setting delta equal to phi? Note that if delta is equal to phi, that means that firms are charging marginal cost, right? They're just, what in this model, labor turns into output. So it means if you're charging, if delta is equal to phi, then you're just charging the cost of paying your labor. So there's no more profits, okay? How does that, explain why that doesn't maximize social welfare? Okay. So a lot of interesting stuff to talk about there. Let's start with part A though. So I find that a good way to start this question is just to look and see where the first time this pricing equation pops up in the slides. So I pulled up the slides here. Here's that guy. All right, so let's see the first time we see WT divided by phi. Here it is, look. So here's the first time we see WT divided by phi. So now we're going to replace this with delta WT divided by phi. That's what the government's going to do. So let's see where we use this PI. We can kind of Scroll down here. Do we see a PI? No, not really. Nothing changes. Is there a PI here? No. No PIs yet. Keep scrolling. Where do we get a PI? Oh, here it is. Okay, I didn't write it here, but this here is the profit of an intermediate producer, and it's price minus cost times quantity. Okay, and you recall the way we got this quantity in equilibrium is just we're taking the total amount of labor and dividing by the number of firms. Okay, so that's going to, and since labor is equal to output in this model, that's your total quantity. Okay, so that doesn't change. What changes here is just there's going to be a delta instead of a 1 here multiplying the wage up here. Okay, so you know, I'm just going to write it just for a second. I'm going to have to erase this, but let me just write it for a second here so you can remember that there's a delta here. Okay, so that's the only change. And then we can look at, we can kind of, I guess we'd have to derive this equation, but it's going to be the same except for this here is going to be delta. If you just, okay, so this is the same as phi divided by phi, right? So now we have delta minus phi divided by phi times wage times this output. Okay, so the only change here is we've got delta here instead of 1. Okay, so let's look at the growth rate. Now, you recall that the growth rate, if you look at this thing, this is actually just the growth rate of WT. If you look at the, so that doesn't change. And this is the growth rate of AT. Okay, so you know, this is just we're just changing the constant out here in front. So actually we're not changing the growth rate of profits. All right, let's double check. I'm pretty sure that's right. But let me actually just quickly double check. Okay, growth rate of Y is this. Growth rate of A is BLA, that doesn't change. Growth rate of Y is this, and then we have an argument that the growth rate of wages, you'll recall, workers are paid a share of output. So we have an argument that wages grow at the same rate as output. There's an argument there somewhere. So here's the growth rate of wages. Here's the growth rate of A. So none of this is affected by the fact that now we have a delta here. Okay, so this doesn't change actually. Growth rate of profits is the same. Nothing here about prices firms are charging, so nothing here changes either. So then we come down here. Okay. So if I look at this zero profit condition, then you can see that here I'm substituting in pi IT. Down here I've got an R minus G. Pi IT, if I scroll up again, is here, and recall that now I have a delta, okay? Okay, so I mean, to summarize it, maybe I can, let me write something actually rather than just do this. So let me get out my external document here. This is now chapter 3.9. That again. Okay, so first change is that pi it is equal to delta minus phi divided by phi, L bar minus LA divided by AT, L bar minus LA divided by AT times WT, if I'm not wrong. Okay. Growth rate of profit is the same as before. R, interest rate is the same as before. I say RT is the same as before. Okay. So, scroll down here. Zero profit condition is now delta minus phi divided by phi. I'm just substituting in this pi from up here. L bar minus LA divided by AT times WT. Okay. Then we're gonna divide by R minus G pi. Okay. So R is this rho plus 1 minus phi divided by phi BLA times 1 divided by rho plus 1 minus phi divided by phi BLA. All right, minus growth rate of profit. What is growth rate of profit? It's up here. 1 minus phi divided by phi BLA. Well, it's just 1 minus 2 phi divided by phi BLA. 1 minus 2 phi divided by phi BLA. Okay. And this has to equal something because it's zero profit condition. Equals W divided by BAT. Okay, so let's simplify this. Let's see here. We've got phi in the denominator, so that stays the same. We've got 1 minus phi minus 1 plus 2 phi. So if I'm not wrong, that's just going to be rho plus BLA. 1 minus 1 minus phi plus 2 phi. So it's just phi. Phi divided by phi is 1, okay? So we'll rewrite that now. Delta minus phi divided by phi L bar minus LA, right, divided by rho plus BLA. All right, here we have an A, here we have an A, here we have a W, here we have a W is equal to 1 divided by B. Is that what I get here? Yeah, well, I just canceled it out, these two things. Okay, so now to solve this model, we need to solve for LA, the number of workers that are in the R&D sector. Okay, so let's go ahead and solve it. The only difference here is we got a delta. Alrighty, what's the easiest way to do this? I think the easiest way is going to be to multiply everything to the other side, except for L bar minus LA here. So let's do that. Let's do L bar minus LA is equal to, oh, I see we've got LA in the denominator too. All right, scratch that. Let's actually just multiply the other side by this rho plus BLA. So we're going to get delta minus phi divided by phi times L bar minus delta minus phi divided by phi LA is equal to rho divided by B plus LA, rho divided by B plus LA, yeah. Okay. Now let's put our LAs on the same side of the equation. So we're going to get LA times 1 plus delta minus phi divided by phi is equal to delta minus phi divided by phi L bar minus rho divided by B. All right. Let's go ahead and well, let's multiply both sides by phi. So we're going to get LA times, it's going to be a phi here plus delta minus phi. So it's actually just going to be delta phi, delta minus phi, yes. Here we're going to get a delta minus phi times L bar. And here we're going to get a phi rho divided by B. All right, let's divide both sides by delta. LA is equal to delta minus phi divided by delta times L bar minus phi rho divided by delta B. Okay, so if we compare, now let's compare this to what we had here. You can see it looks very similar. The only difference is now we have delta minus phi divided by delta, and here we have phi divided by delta. Okay, so yeah, let's stay there for a second. All right, now you recall that we can now look at growth of output. Okay, so what is our growth of output? It's just 1 minus phi divided by phi BLA. Oops, need to have another page here. So this one. Yes. Okay, so output now, growth of output is 1 minus phi divided by phi BLA. 1 minus phi divided by phi BLA. Okay, plug in our LA there. I'll call this GY. Okay, so we're going to get, let's see here, 1 minus phi divided by phi times B, and then delta minus phi divided by delta, L bar minus phi divided by delta, rho divided by B. All right, how can we make this look simpler? Not sure that it gets much simpler than that. I mean, we can multiply it through and see what happens. 1 minus phi times delta minus phi divided by phi delta B times L bar minus, and then here we're going to get a 1 minus phi divided by delta. The B's are going to cancel times rho. Get that right? Delta cancel, 1 minus phi divided by delta, B's cancel. Yeah, I think that's right. All right, I think that that's about as simple as it's going to get. Well, Factor out the 1 minus phi divided by delta. That make it easier or harder? Yeah. Let's factor it because it's going to make taking the derivative easier, and I think that's we're going to be doing that in a second. So here I've got a 1 minus phi and a delta. Here I've got a 1 minus phi and a delta. So let's take those up front. 1 minus phi divided by delta. Delta minus phi divided by phi. B L bar minus rho. Did I miss something? Somebody unmuted. Nope. Okay, so that's it. We can compare it to what we had in the slides. 1 minus phi squared divided by phi, 1 minus phi. I guess maybe it's easiest to look here. Previously, this was a 1, right? Previously, this was a 1. So it would have been 1 minus phi squared divided by phi, and then 1 minus phi. So you can just see the deltas just kind of pop up in there, but when delta is 1, then it's going to look the same as this expression. Not surprising. Okay. So last thing we need to do is we want to take the derivative of this thing with respect to delta. We want to see how it changes. We've got one delta in the denominator, one in the numerator, so it's not obvious exactly how this is going to change. It could go up, it could go down. So we're going to take derivative with respect to delta. Okay. So first, let's take the derivative out here. So we're going to get, let's see here, phi minus 1 divided by delta squared times delta minus phi divided by phi B L bar minus rho. Okay. Plus 1 minus phi delta, and then we derivative in here. It's just going to be B L bar divided by phi. Okay. Looks like we can simplify a little bit here. So you can see here that I've got, okay, let's do a little bit of multiplication. I'm going to do a phi minus 1 times delta divided by delta squared. Phi minus 1 times delta divided by delta squared times B L bar divided by phi. Then here we're going to have a plus 1 minus phi times phi divided by phi. Delta squared. Is that right? 1 minus phi times phi. Yes. Times BL bar divided by phi minus phi minus 1 divided by delta squared times rho plus 1 minus phi, this is the nice part, divided by delta squared. I multiplied the top and the bottom by delta times BL bar divided by phi. And check this out. This term here is actually the opposite of this term here. Since I've got 1 minus phi here and a phi minus 1, these two terms actually cancel. Okay. Going back to black, what do we have left? We've got 1 minus phi. Here we've got to find the numerator and the denominator. I'll cancel that. Divided by delta squared. BL bar divided by phi. Here I've got a minus, but phi is something, a number that's less than 1. So I'm going to turn this around and have plus 1 minus phi divided by delta squared times rho. And that's it. Okay. So that was a lot of calculation, but what's the point? The point is that this thing here is greater than 0. So what this says is that when we increase delta, then the economy is going to grow faster. Okay, so now we are actually at the end of the first question. So if we look at the problem, it says, what is the equilibrium growth rate of the economy as a function of delta and the other parameters of the model? Does a reduction in delta increase, decrease, or have no effect on the equilibrium growth rate, or is it not possible to tell? Okay, so what this says is that when we increase delta, then the economy grows faster. So if we decrease delta, the economy grows slower. So here what we get is that a decrease in delta slows economic growth. All right, and that is the end of part A. Part A is done. All right, let's go to part B. And part B is just intuition. It's easy, no math. So what part B says is, why is it that setting delta equal to phi is not optimal? Now, remember that this economy suffers maybe from market power. Here we have a monopolist. We have monopolistic competition. All right. So because there's monopolists in here, we have less output than is socially optimal. Okay. That force is still operating here. They're setting the price above marginal cost. All right. So why is it not true in this model that as the planner, we can actually do the best we possibly can by setting delta equal to phi, so that going all the way up here, if we set delta equal to phi, well, then we're just going to, then the price is going to be equal to marginal cost. And what happens, you see that the profit of the monopolists goes away. That means we're in a zero profit world, perfect competition. This is like Econ 101. We love this stuff, right? They've got all kinds of firms that are competing with each other. They're not making any profit. All the benefits are going to the consumers. Why is that not optimal in this economy? How could it not be optimal to force firms to charge marginal cost? So I'll wait for you guys to answer that. Anybody have an answer for that one? You can see that we are only the few and the proud now.
All right. Proudest of them all, right?
I can hear you.
Yeah. We said that the removal of the markup would reduce profits, thus removing all incentive to create new ideas and stagnate the economy, leading to no welfare. And then we said no welfare is definitely not socially optimal.
Exactly. So I don't think I'd go quite as far as you went. So you are right that if we set delta equal to phi, then there will actually be no growth. Why would anybody spend money on inventing a new idea if they're not going to be able to make any profit? It's like, it's costly. It costs you something, and there's no profit that you'll ever make. The zero profit condition is going to say that no one will ever invent any new ideas. So let me say that economic growth would shut down. Economic growth would end. Okay. So that's true, but I don't think the welfare actually goes to zero. So there still are ideas that are existing in the economy. Okay. I'm just going to finish this and say this can't be optimal. This is unlikely to be optimal. Unlikely to be socially optimal. In fact, I think you can show that it's not socially optimal using math. But there's actually an interesting trade-off here. Okay, so So we can show that when we lower delta, it slows down economic growth. But there is that other force. Okay, there is the other force that when we reduce delta, it benefits consumers because it sort of takes away some of the monopoly power of the producers, of the monopolists in this economy. So there's two concepts here, and actually they're really important concepts. One is static efficiency, and one is dynamic efficiency. So usually when, like in, say, your micro course from your undergrad, when you study monopolists, you're studying a static problem. Okay, and there in the static problem, you do want to shut down the markup. If you can force those monopolists to charge marginal cost, that's going to be the best for the economy. And in fact, that force is still operating here. In a static way, the consumers are actually going to be better off from reducing the markup. I think you can actually see it somewhere. I'm not sure exactly where. Probably just the zero profit condition is the right place to look. But you know, that still benefits consumers. It's just that that's not the only thing we care about. We also care about what's happening along this, you know, growth path. So that's going to shut down the future sort of increasing path of consumption. So it's kind of like we're giving people more right now by sort of tilting down the way that the economy grows. And you know, we can keep tilting, right? If we keep pushing delta down, you know, that growth is getting lower and lower, but our static consumption is actually increasing. So you know, there's a trade-off there. There's a trade-off between in terms of market power, there's a trade-off between our static gains and our dynamic losses. Okay, and we see that. So again, this model is really about, my picture disappeared. Oh, I don't know what happened. Anyway, I'll get rid of this thing. But you know, there's this interesting trade-off, and basically, you know, we have a patent system, and the idea is that patent system is going to kind of find the sweet spot. You know, patents are supposed to last for a certain number of years, not forever. We want to give firms enough incentive, but not too much incentive, because we don't want there to be permanent monopolies. You know, there is this trade-off going on, basically. So I think I'm losing people now. So I will call it quits for the day. But I think next time you guys are going to be reading about the Lucas Islands or imperfect information model. And that's another nice sort of extension of Macro 101. So I look forward to talking.
Before you leave,
Absolutely.
could you turn off the recording and can I ask you a few questions?
Absolutely.
Thank you.
Let me do that quickly, but I don't quite. Oh, here it is. Stop.